This is Venkatesham. Thanks for watching this video, and please subscribe to my channel Venkatesham Dongala. And if you like this video, and share it to your friends and neighbors, and then don't forget to subscribe my channel, that is Venkatesham Dongala. And then please subscribe, and then don't forget to comment on that given box. Thank you. I am going to explain that ionic product of water. We hear ionic product of water, it will be there. This ionic product of water topic, so as all we know that pure water is a bad conductor of heat and electricity, and even then it can ionize to a small extent, and it will be ionized to a smaller extent, and it will produces the H plus and OH minus ions. Whereas this H plus ions are the bare ions, and we can say that always this exist with a particularly another water molecule, and it can form as a H3O plus ions, right? So I can write here there is an exist equilibrium between the H2O molecule and dissociated ions. So I am taking that this H2O is a pure conductor or a bad conductor of heat and electricity. When it is mixed with any other salt, then it can act as a good conductor of heat and electricity. But actually pure water is a bad conductor of heat and electricity, and it will be dissociated into the smaller ions like H plus ion, and then and it's OH minus ions. Right, this H plus ion, whatever it is produced, this H plus ion is going to be which is a bare ion. It cannot exist independently. Always it is going to be combined with another water molecule, and it can form as it's a H3O plus ions. So I can write that there is in this case particularly there exists a equilibrium between the dissociated ions and undissociated H2O molecule. Whenever there is an equilibrium is existed, then we can write further there is a equilibrium constant can be written. As all we know that this equilibrium constant can be written based on the purely based on the law of mass action. This law of mass action was proposed by the Vage and Gulberge scientists. According to that Vage and Gulberge, as all we know that there is an equilibrium constant is simply a ratio between the product of molar concentrations of product to the product of molar concentration of reactant. That ratio is simply a equilibrium constant, right? I can write here equilibrium constant particularly for this reaction. So there is an equilibrium constant K is equals to, so here H plus and OH minus ions are the product, so that I can write a molar concentration of H plus into this is in a molar concentration of here OH minus ions. Product of molar concentration of products to product of molar concentration of reactant. Reactant, there is only one reactant molecule is there, that I can write down this is a H2O. Okay, so this H plus and OH minus ion concentration product divided by here H2O ion concentration. So whenever I am taking this H2O into this side, so I will write this is in a K into H2O concentration. So that is equals to, so simply I can write this is in a H plus ion concentration into this is in a here OH minus ion concentration. So and this K into H2O concentration we can write down, product of this K into H2O concentration will write down, it can be represented with another constant as this is the ionic product of water, and I can write this is in a KW is equals to, simply I can write this is in a K into H2O concentration, and this can be represented with the KW. So that from this suppose if we take this is equation 1 and this is equation 2, from equation 1 and 2 I can write that so from equation there is an 1 and 2, I can write that there is an KW is equals to, simply I can write this as an H plus ion concentration into here it is in a OH minus ion concentration. So simply ionic product of water can be defined as the product of H plus ion concentration into OH minus ion concentration at a given temperature. At a given temperature, why I am using this at a given temperature means because at a given temperature its value is going to be a constant. That's the reason, or we can tell that as the temperature will affect on the concentration of H plus and concentration of OH minus, definitely we can write this Kw value is, it purely depends upon the temperature. That's the reason I can write this is simply Kw value at a given temperature only, it is the product of molar concentration of H plus into molar concentration of OH minus. So that I can write this is simply at generally at room temperature condition. At room temperature condition is that is at 25 degrees centigrade. I can write this is in a Kw value is a constant that always will write down the 1 into 10 power minus 14 so mole square for liter square, mole square for liter square. This value is a constant at a room temperature at a 25 degrees centigrade. Its value is going to be constant, right? So whereas in the case of other temperature, its value will be definitely changes, right? I can write here it is in this water is a pure conductor and it is a neutral solution. So from that I can write this water is a neutral solution, so that I can write this is in this neutral solution. Again it is having the generally H plus ion concentration and OH minus ion concentration value will be equal. I can write this is enough for neutral solution. Here H plus ion concentration is equals to, I can write this is an OH minus ion concentration. Okay, so both are equal. For a neutral solution, H plus ion concentration should be equals to the OH minus ion concentration, so that you can substitute in the above equation. Kw value is a 1 into 10 power minus 14, whereas this H plus ion concentration should be equals to OH minus. You can write this equation can be written as here 1 into 10 power minus 14, that is equals to, simply I can write here H plus ion concentration into, here it is in H plus ion concentration. Okay, so from this I can write this is simply H plus ion concentration is equals to, which is the square root of 10 power minus 14. Okay, so simply from that I can write there is an here H plus ion concentration should be equals to the, here it is an OH minus ion concentration, which will be equals to the 10 power minus 7, right? For a neutral solution, its H plus ion concentration should be equals to the here OH minus ion concentration, right? So generally, and from this ionic product of water, generally H plus ion concentration equals to OH minus ion concentration, that equals to, it's the 10 power minus 14, right? Here based on this particular, actually here I can say that this Kw value, whatever I am using this Kw value, this Kw value is it purely depends upon the temperature. As the temperature changes, definitely Kw value also going to be changes. As the temperature increases, then Kw value also increases. As the temperature decreases, Kw value also decreases. That's the reason that directly proportional to the its a temperature I can write. And based on the amounts of H plus ion concentration and OH minus ion concentration, we can tell that we can classify the solutions into mainly three types. So mainly there is three types of solutions are there. So based on the amount of H plus ion concentration and amount of OH minus ion concentration, the solutions are mainly three types are there. So one I can write there is this is purely based on the amounts of this H plus ion concentration and OH minus ion concentration, so that I can write solutions are mainly there is three types are there. So first one is I can write this is a neutral solution. Neutral solution is one. In this neutral solution, both H plus ion concentration should be equals to the, here it is now OH minus ion concentration, and so such a solution is your neutral solution. If you will take it room temperature condition, its value should be equals to the 10 power minus 7 moles per liter, right? So second one is there is an acidic solution. In this acidic solution, I can write there is an H plus ion concentration is dominating than the OH minus ion concentration. Whenever there is in a given solution, if H plus ion concentration is more than the here OH minus ion concentration, like this I can write here H plus ion concentration is more than the here OH minus ion concentration. Such a solution is called it's a acidic solution. In the acidic solution, always you find that there is an H plus ion concentration is greater than the here 10 power minus 7. 10 power minus 7 greater than means its a value, it may be the 10 power minus 6, or it may be a 10 power minus 5, it may be a 10 power minus 4, it may be a 10 power minus 3, like that you can write. But don't see that negative value. 10 power negative means that value will be the lower. So 10 power minus 6 minus 5 minus 4 means its value is more, right? And even I can write this is an OH minus ion concentration should be, which is less than the, so this is a 10 power minus 7 I can write. Okay, 10 power minus 7 means you can write this is a 10 power minus 8, 10 power minus 9, 10 power minus 10, like that you can write. So this is a condition in the case of acidic solution. Generally H plus ion concentration is dominating than the OH minus ion concentration. Such a solution is a acidic solution. And the third one is here basic solution. In this basic solution, I can write this is a quite reversal, and here OH minus ion concentration is more than the here H plus ion concentration, right? So generally here OH minus ion concentration value is so we can take it as it's a value. So in the same way there is enough OH minus ion concentration value will be the, so its a value will be here greater than the 10 power minus 7, and whereas in the case of its OH minus ion concentration, the H plus ion concentration should be, which will be the this is less than the 10 power minus 7, right? So here this is a condition for the basic solution, acidic solution, as well as the neutral solution, right? So this is a simply ionic product of water. In this ionic product of water, you find that simply by taking the pure water and it's a dissociation, and it will be the ionic equilibrium constant is introduced. From that there is a ionic product constant is introduced. So then again it depends on temperature, classification of solutions. Better you can make a note